All right. Well, thanks so much. I really appreciate the kind invitation to come and speak with you all. You have a really, really nice campus here, and I've really enjoyed meeting all the faculty and students in the department. So thank you for having me. I am at Virginia Tech, as Dr. Kabura said. Our department is human nutrition, foods, and exercise. So we're an integrated department. I'm also a faculty member in a program called Water Interface. It's an interdisciplinary PhD program that offers graduate certificates. And that allows me to work with faculty in areas across the campus in microbiology, in civil engineering, in food science and technology to train students and to engage in research that impact from pipes to people. So a lot of aspects of water and health, the water quality, water aesthetics, whether or not what comes out of your shower head gets aerosolized, and that could cause health problems, lots of different really interesting areas. So that's been a great learning experience for me. And I'll talk a little bit about some of the interdisciplinary work that we've done if I have time at the end here. Let's see. All right, so. We're not advancing. Okay, so arrows now. Yes, perfect. Okay. So I am from Virginia Tech, and it has some things in common, I think, with the University of Arkansas. We are a land-grant institution. We do have cows on our campus. This is a cow on our drill field. I don't know why the cow is on the drill field, but I thought this was a nice illustration of some of the areas like animal science that are very prominent at Virginia Tech. We are in the Blue Ridge Mountains in southwestern Virginia, so if you like the outdoors, it's a really beautiful place to be. And great opportunities for recreation, hiking, and biking, and those sorts of things. So very nice campus. It is a small college town, though, so if folks are really big city lovers, it's probably not the place for you. My laboratory is focused on research investigating eating behaviors and weight management. And the overarching theme is obesity prevention and treatment, but I have 3 focus areas that I'm particularly interested in studying. I'm interested in designing interventions that can help folks improve their health behaviors, whether that's diet or physical activity. I'm very interested in dietary assessments. So are there ways that we could design methods to better assess dietary intake, both using self-report, but also biomarkers? And can we develop assessment methods that would be useful not only in research settings, but also for health practitioners in clinical settings? And then lastly, what we'll focus on today, I'm very interested in water consumption and really beverage consumption in general and body weight management. So this slide, it's very busy, and you don't need to see all the details on here, but this is a really nice slide that the Obesity Society developed. When we used to think about obesity prevention and treatment 2 decades ago, we really just talked about energy intake and energy expenditure, and we didn't get into a whole lot more detail than that. And now in 2015, we are just learning more and more and more about how complex this problem is. And so it's very humbling when you're studying obesity prevention and treatment to look at a slide like this to see how you fit in. I got into this area because I was really interested in aging and body weight management. We normally gain weight with advancing age, so why is that? That was really what started me with this. But I'm also interested in food intake regulation and also beverage availability, our consumption of high-calorie, nutrient-poor beverages and how that impacts health. So those are the areas that we'll talk about a little bit today. And this is my story in the Davy Lab. I am a Twitter fan, and if you all are on Twitter, you are welcome to get your phones out and tweet during the talk. My Twitter handle is @DavyBrenda, so you can add me on there. And we also have a hashtag for my lab group that we share with my chocolate lab Stella, who's 2 years old. So you'll see two Davy Lab streams going on there at the same time. But this is really our story of the research that we've done over about the past decade to get into this area of water and weight management. And as I mentioned, it really all started with this issue of weight gain and aging, and why does that happen? And I was really interested in how physical activity might impact that. And so we know that with advancing age, there's a decline in energy expenditure, so changes in body composition that would lead to a reduction in resting metabolic rate. There's a decline in energy expended in physical activity. And there also seems to be an increase in food intake relative to energy expenditure. And so this has been referred to as energy intake dysregulation, or inaccurate regulation of our food intake. So we can't accurately match our intake and expenditure. If we were, our weight would remain stable. But with aging, there's a mismatch there, and so we tend to gain weight. So this is what led us to do the very first study that launched this line of research. We recruited 4 groups of individuals, older and younger adults, so about 20 to 35 years old versus 55 to 75 years old. We recruited both active and sedentary individuals. And we had them come into the laboratory on a couple of different occasions to do these acute test meal studies. And because these relate to the water studies that we conducted after that, I wanted to explain a little bit about how we do these. With these studies, what you are able to do is bring folks into the lab and give them an ad libitum meal. You ask them to eat freely, as much as they want, and you give them a big table full of food so they can choose whatever they want. You do that on one occasion. On another occasion, you give them a calorie-containing preload, kind of like an appetizer. And when you give them the appetizer, then within 20 or 30 minutes, you expose them to this table of food, and you study how much they eat following this preload. If someone is really accurately regulating their food intake, they'll eat about the same number of total calories both times you bring them into the lab. If they tend to eat more after that preload, so that their total calorie intake, the preload plus the test meal intake, is higher than that condition where they were just exposed to the table of food and ate from that, then that tells you something about how accurately they regulate their food intake. So do you appropriately adjust your food intake down when you're exposed to all that food to account for the calories in that appetizer or that preload? Okay, so that's how we do these types of studies, or the preloading studies. Okay, and so since you guys are physical activity folks, I wanted to tell you a little bit about our results here. So again, we had 2 lunch meal conditions in a randomly assigned order. We had our study participants write down everything that they ate and drank for the rest of the day following our test meal, because we were not only interested in that test meal, but also what happens for the rest of the day. So we had those 2 different conditions. We compared their total calorie intake at those 2 different conditions. If they were accurately regulating their food intake, they would eat the same number of calories on those 2 occasions. And so what you would see up here would be 100% compensation. They would accurately regulate their food intake. If they're below that, then that means that they are overeating. They're eating excess calories in that condition with the preload. And so what you can see here with the top panel is that the ability to accurately compensate for those preload calories, which was a yogurt drink of about 300 or 400 calories, it was a lot lower in the older folks compared to the younger folks. So the younger folks were much more able to accurately regulate their food intake. The older folks were not, and it didn't matter whether they were active or sedentary. So what we did, though, after that was look at their calorie intake for the test meal and the remainder of the day to see if maybe later on in the day the active folks make up for those calories so that they're eating appropriately over the course of most of the day. And in fact, we did find that over the course of the day, the physically active individuals were able to accurately regulate their food intake. So not at the test meal, but over the course of the rest of the day. So the take-home points here are that with aging, with older adults exposed to this kind of condition, they're prone to overeating. The other take-home point was that there is something about physical activity that improves our ability to sense hunger and eat appropriately. So balance may occur more accurately over the course of a day in physically active individuals. Okay, so why focus on water? Well, when we designed those studies, we were really trying to build upon some previous research on this topic. And so we compared no preload to this calorie-containing yogurt drink preload. That was how we designed the study. But we were thinking about water ingestion, and we were thinking about a volume of liquid in the stomach and how that might, in and of itself, influence how much someone eats at that ad lib food intake situation. And so, there was this idea that water could suppress hunger and help individuals reduce their calorie intake, but there had not been any studies done comparing younger and older individuals with a water preload condition compared to no preload. Okay, so this led to the next series of studies that we did. Okay, and so those were these two studies here. What we did was very similar to that first study. We had individuals come into the lab on 2 different occasions. On one occasion, we did not give them a preload. We gave them a big tray full of food to choose from. On the other occasion, we gave them 500 milliliters, or about 2 cups of water as a preload. And then 30 minutes later, we had them eat freely from this big tray of food. Okay, so it was a no preload versus a water preload condition. And what we found was that in the young individuals, it did not matter. They ate exactly the same amount of calories on those 2 occasions. And so you can see they ate about 900 calories at each of those test meals. What happened in the older folks, though, shown on this side, is that they ate about 90 calories less following this water preload. And so we were very interested in this finding, and we thought possibly the aging issue here is gastric emptying is delayed with advancing age, and so that may be why there's not an effect in younger people, but this is effective in older people as a way to reduce their meal calorie intake. And so we wanted to investigate this as a weight loss strategy, and so this first study was done in non-obese individuals, and we replicated that study in a group of overweight and obese older individuals. And the magnitude of reduction in meal calorie intake was very similar. In one study, it was about 70 calories, and one study was about 90 calories. Okay. So around this time, there was really this growing appreciation for beverage intake and calories, and how maybe this is changing in the same way that our obesity prevalence is rising. And so our usual beverage calorie intake in the U.S. is about 450 calories a day. So beverages represent a significant source of our daily calories. About half of those calories are from sugar-sweetened beverages, so nutrient-poor, higher-calorie beverages. And the World Health Organization at this time had also suggested that fruit drinks and soft drinks were a dietary factor probably linked to weight gain and obesity. There was also growing recognition that food form is really important. Whether you're ingesting liquid calories or solid calories, it does seem to make a difference in terms of your ability to maintain energy balance. And so some of this came from studies like those done in Barbara Roll's laboratory at Penn State, where she would match calories and the weight of food and give different forms of a food as a preload. and then study meal calorie intake. And what she found was that folks tend to eat a lot less of that test meal when the food is more of a solid form. It's more satiating. They are not as hungry, so they eat less when they're exposed to that test meal. In contrast, when folks are given liquid forms of calories like the apple juice, they tended to overconsume calories at that test meal. So food form does seem to be very important in helping us manage our calorie intake. Okay. This figure here illustrates this, I think, pretty nicely. So you can see across the x-axis, you have a variety of different beverages here. And then the number of calories at the test meal here. And what this shows you is that beverage calories, whether it's soft drinks or juice or milk, that's additive to those solid food calories at a meal. And so you consume fewer calories at a meal when you are consuming either nothing or water or a diet drink. So beverage calories appear to be additive to meal calorie intake. So again, around this time, there was this growing appreciation for the role of water as an alternative to calorie-containing beverages. So the Surgeon General's report in 2010 was promoting drinking more water rather than calorie-containing beverages. The dietary guidelines in 2010 also recommended drink water instead of sugary drinks. And that was one of their 7 key messages for consumers out of the 2010 guidelines. This year, the 2015 dietary guidelines committee report was released. And again, they really emphasized the importance of water consumption. And they went farther than these previous recommendations and suggested that water be made the preferred beverage, that water should be encouraged when folks are thirsty, and that water should be accessible in public settings, such as schools and work sites and other community places where beverages are offered. Yet there was a fairly limited amount of evidence that supported a lot of these recommendations, particularly the earlier ones. So in my laboratory, we were very interested in this idea of replacing beverage calories with water, using water consumption as a weight management strategy to help folks control their hunger and to eat less. And we were also interested in some of the other health benefits of water. Okay, so what did we know? There were very few studies at this time that really directly addressed this issue of water consumption and weight management. We had some epidemiological studies, so observational studies over time. We had a few of these meal studies, like the ones that we did in our laboratory. And there was a secondary analysis of a year-long weight loss trial that was really focused on comparing some different diets. But they did evaluate water consumption, and that was pretty much what we had at that time. As of 2010, there were no randomized controlled intervention trials evaluating water consumption as a weight loss strategy. Okay. So what we knew from the epidemiological research was that water consumers seem to consume fewer calories over the course of a day. They seem to consume about 200 fewer calories as compared to individuals who weren't water consumers. They also had healthier overall dietary patterns. And the secondary analysis of that 12-month weight loss trial reported that individuals who consumed more than 1 liter of water per day had about a 2 kilogram greater weight loss over this 1-year period of time. Okay. Okay, so the next step then was really a randomized control trial. This was really the type of study that needed to be done to evaluate water consumption. And so this is the study that we spent a couple of years doing and published in 2010. What we did for this study was really build upon our acute test meal studies, those lab-based studies. We recruited older individuals, middle-aged and older individuals who were either overweight or obese. We didn't screen them for baseline water consumption, but we did collect that information. We found that in this group of older adults, their usual water consumption was only about 300 to 400 milliliters per day, which is pretty consistent with larger studies. That represents 1 to 2 cups of water per day. So water consumption was very, very low in these middle-aged and older adults. What we had them do was participate in a 12-week-long trial. All individuals were instructed in a low-calorie diet, 1,200 calories for women, 1,500 calories for men. We had them, half of the group was randomly assigned to a pre-meal water condition where they drank 2 cups or 500 milliliters of water about 30 minutes before each of those main meals. So kind of extending those lab studies. We had them come back into the laboratory once a week to tell them how they were doing as far as the weight loss diet, to check their body weight, and to make sure they were complying with the pre-meal water. And to help them with compliance, we provided them with the bottled water to drink 3 times a day. Okay. The participants in this study weren't really aware of the 2 conditions. We didn't want them to know exactly what we were doing because that can influence your study results. And so folks in the other condition, we gave them fresh fruit. We gave them bags of apples and oranges. So they thought they were in an intervention condition as well. So that's how we sort of kept folks blinded to what we were actually doing. Okay. And so what we found was that after 12 weeks, we found that weight loss in our pre-meal water group was about 2 kilograms greater than our comparison group. So both groups did very well. Weight loss was 15.5 pounds in the water group and 11 pounds in the comparison group. But we did seem to have pretty good evidence at this point that the pre-meal water strategy seemed to somehow facilitate some extra weight loss. So, Dr. Kaboris, can I X out the little box here, or will that disrupt the recording? Okay, sorry. Can't have you miss the figures, right? Everyone loves the figures, right? Okay. So basically, these figures are just growth curve analyses showing the weekly weight loss over the 12 weeks in our 2 groups, okay? The water group on the far panel and the non-water group on the near panel. So then the big limitation, though, here is that I can't advance again, so that is one of the limitations. All right. So just hit space and then arrow down. Sorry about that.
Is it the next?
That's fine. Yeah, that works. I'll go with it.
Did you have another overhead between?
No, that's good. Yeah, thank you. Sorry about that. So then the question is, so you've done a 12-week weight loss study, and it looks like you have good results. Well, what happens after that? That's really the challenge there is maintaining that weight loss over time. And so that was the next analysis that we did as part of this line of work. We followed those participants for an additional year after the weight loss trial. We had them continue, the water group, we had them continue with this 3 times a day pre-meal water before their main meals. And the other group just continued doing what they were doing. At this point, we didn't really have a calorie restriction level, though. What we asked them to do each day, though, is to track their daily step counts. We gave everybody pedometers and a 10,000 step per day goal for this step counts. We had them track their fruit and vegetable intake, so aim for 5 servings of fruits and vegetables per day. And we had them track their body weight, because for weight loss maintenance, self-monitoring or tracking of your body weight appears to be one of those factors that is associated with being successful at keeping the weight off after you've undergone weight loss. So we just had them track a couple of these behaviors, not overall calories. And what we found was that, okay, we've got a Mac to PC problem here. Sorry about that. What we found, if you'll just look at the black lines in there, those are, again, the weight changes. We found that after a year, folks in the water group were still a pound below their new reduced weight. So not only did they lose weight and keep it off, they lost about a pound more over the course of a year. Folks in the non-water group still did pretty well. They still were pretty close to where they finished at the end of the weight loss component of the study, but they were on an upward trajectory, and they were about a kilogram higher. So still pretty good results in terms of weight loss maintenance, but again, there seemed to be some benefit here to the pre-meal water consumption. And when we looked at we had 365 days of self-monitoring data on each of our study participants for water, step counts, fruit and vegetable intake, body weight. What we found that we thought was very interesting was that with the water group, they were much more adherent to this daily step count goal. So that got us thinking about hydration and adherence to an exercise regimen, and we wanted to follow up to that. So we'll come back to that in a little bit later. So not too long after that, Deb Tate, who's a faculty member down at UNC Chapel Hill, published a study called the Choice Trial, and she had 3 intervention groups, and each group was supposed to reduce their calorie intake by about 200 calories. One group could just make a diet change of their choice. It was up to them. They were sort of the control group. The water replacement group was supposed to substitute water for a calorie-containing beverage. And then there was a diet beverage group that substituted diet beverages for about 200 calories. This was a 6-month study. They came in monthly for weight checks and did some online tracking and reporting. Okay. Looks like I've lost some text here at the bottom. So what I'll just tell you, though, is that with the findings, there weren't any differences in weight loss over the course of the 6 months across those 3 groups. The mean values look a little bit different, but statistically there wasn't a difference there. Okay, but what they found that was pretty interesting was that the diet beverage group seemed to do a little bit better in terms of achieving 5% weight loss. And 5% weight loss is thought to be a clinically meaningful weight loss goal. It's associated with a lot of benefits in terms of health outcomes. So the diet beverage group did better in meeting that weight loss goal. But interestingly, in the water group, they found that fasting blood glucose concentrations were lower after 6 months. So we, again, thought that was a very interesting finding, and maybe that's something that we needed to follow up on. Sorry, it's stuck again. I think this pop-up is... Okay. All right. So then we had a couple of issues that we were interested in after doing these series of studies. One of the things that we learned was that it was really difficult in our studies to evaluate habitual or usual beverage intake. We manually went through a lot of food records to extract beverage variables to get a lot of our beverage intake data. And so we thought there must be an easier way to evaluate water and sugar sweetened beverages, and maybe there's some kind of contribution we can make there. We were also interested in developing a tool that consumers or health practitioners could use to evaluate overall beverage intake. So thinking beyond water or sugar-sweetened beverages, could we develop a tool to evaluate someone's beverage intake habits and maybe guide them to make changes that would be associated with health benefits? So we were interested in a couple of things there. We were also interested in some of these other issues related to water consumption, such as diabetes risk reduction because of this improvement in fasting glucose in the CHOICE trial, and also cognitive function. We had this observation that our water group folks were better able to comply with our physical activity recommendations. So maybe there was something there related to physical activity adherence and cognitive function. Okay. So related to diabetes and glucose tolerance, and here is where I will get myself into trouble because I think Dr. Kavoris and those in his lab are probably stronger with much of this research. But there were a couple of things that were important to note about diabetes and glucose tolerance. Individuals who have poorly controlled diabetes are at greater risk for dehydration. And dehydration also seemed to be related to poor glucose tolerance. So perhaps there was a vicious cycle there related to diabetes and hydration status. Okay, so that was something that we thought was interesting. And then Dr. Jody Struki published a paper showing that this issue of cellular dehydration seemed to be associated with impairments in blood glucose and insulin metabolism. So that individuals in her study who had this cellular dehydration that was associated with insulin resistance, with impaired glucose tolerance, and with greater diabetes risk. Okay, so like a lot of scientists, we had stockpiled some blood samples from our water study, and so we went over to our -80 and pulled out some samples to determine whether or not our water group could give us any more information on this link between diabetes risk, glucose metabolism, and water consumption. And so this was just a little small pilot study that we did. We didn't find any group differences, so the water group versus the comparison group, no differences there. But in the group as a whole, we did find that plasma insulin and HOMA-IR, which is an indicator of insulin resistance, were associated with urinary specific gravity, which is an indicator of hydration status. We also found that fasting insulin concentrations were improved in our water group participants relative to the other participants. So this was something that we hope to follow up on. Okay, a little bit on cognitive function. So there have been a few really nice studies that have shown that dehydration and even low levels of dehydration, those commonly encountered as we go throughout our day, are associated with impaired mental function and motor control. So 2 to 3% dehydration could lead to some short and long-term memory problems, impaired attention and alertness, impairments in math abilities. The mechanisms, as far as I know, have not been determined at this point. But one of the studies that I think is really great evidence for this was a study done in the Armstrong lab. And they studied both men and women, but I'll just present the results here from the group of women. In these studies, they induced mild levels of dehydration, so about 1% dehydration, which is probably common in all of us just as we go throughout our typical weekly routines. So after inducing dehydration, they did a battery of cognitive function tests. And what they found, even with this low level of dehydration, they found that the women reported increases in anger and hostility and fatigue and decreased vigor. They also reported mood disturbances, headaches, and a decreased ability to concentrate. So again, this is only about 1% dehydration. Okay. So we're thinking, of course, about our long-term weight maintenance study and motivation to exercise. And maybe if someone is slightly chronically dehydrated, this could lead them to feel like they have less energy to engage in physical activity. And in these series of studies, they reported similar results in men. Okay. Some other benefits that have been reported related to water consumption are reduced risk of urinary tract infections, reduced risk of gall and kidney stones, and that's at water intake levels of greater than 2.5 liters a day, so about 10 cups per day. A reduced risk of bladder cancer, colorectal cancer and polyps, and also fatal coronary heart disease, with individuals consuming greater than 1 liter of water a day compared to 1/2 liter of water a day. So about 4 cups of water per day. Okay. The challenge here is that there have been very few studies, and most of those that have been done have had very small sample sizes. So there's still a lot of work that needs to be done here. And a lot of these studies were associative studies. They weren't cause and effect types of studies. Okay. So back to intake recommendations. Consumers will tell you that, related to dietary intake in particular, they want simple, specific, quantifiable recommendations for how they can improve their health habits. And unfortunately, when it comes to water intake, we do not have a lot of good recommendations. Dr. Barry Popkin convened a group of experts and developed some guidelines. That it was called the Beverage Guidance Panel. So we do have that set of recommendations. The Robert Wood Johnson Foundation has a set of intake recommendations, again, not very quantitative though. And then the Institute of Medicine has the DRI for water, which really relates to total fluid intake, not necessarily drinking water intake. So still consumers don't have a lot to go by. And so I was fortunate to work with a new colleague, Kaya Duffy, who had worked with Barry Popkin. She's a nutritional epidemiologist. And she has tremendous skills as an epidemiologist, skills that I don't have, but was really, really happy to be able to collaborate with someone who had that skill set. So we had this idea of a healthy beverage index, kind of like the healthy eating index developed by the USDA. So we set out to devise a set of guidelines. We pulled together the Beverage Guidance Panel, the DRIs, the Robert Wood Johnson Foundation recommendations, and came up with a couple of different scoring algorithms for different beverage consumption categories. And we evaluated those using NHANES data. And what we found was that with this beverage index that we developed, a 100-point index, with each 10-point increase in the Healthy Beverage Index score, we found a reduced cardiometabolic risk. So we found lower risk of hypertension. We found lower fasting insulin and glucose concentrations, and some improvements or some benefits as to blood lipid levels, HDL and LDL, and also C-reactive protein. So this kind of gave us some proof of concept for these index that we had developed, that it did have some connection to health outcomes. What we hope to do in the future, in the near future, is develop an online version for this so that consumers who are interested in evaluating their beverage consumption could access something and very easily figure out how they're doing and how they might improve their habits. And also something for children. I think a lot of parents are concerned about their children's sugary beverage intake and really aren't sure how much would be okay and how much of other beverages would be appropriate. So those are some things that we hope to do. Okay. If you're interested, we've published these results, and this table is in that publication. But this just gives you a sense of the different beverage categories that we have. So we have 8 categories of beverages, and then an intake recommendation for each of those. Okay, so water would be the one on top, and we allocated points to beverages that we thought had the most strong connection to health benefits. So water, sugar-sweetened beverages, total beverage energy or total beverage calories, and total fluid requirements were the categories that we allocated the greatest number of points to. Okay? So with water, the goal there for a healthy beverage intake would be at least 20% of your total fluid needs are coming from your water intake. Okay, so you're drinking that amount of water and you get 15 points for doing that. Okay. For sugar-sweetened beverages, if you consumed 0 to 8% of your calories from sugar-sweetened beverages, then you would get the full number of points there. For total beverage calories, if your beverage calorie consumption was less than 10% of your total calorie needs, then you would get the full amount of points there. And then total fluid requirements. And the guideline that we used for total fluid requirements was that used in the DRIs. It's likely an underestimate, but your fluid needs are somewhat related to your daily calorie requirements in kind of a 1-to-1 ratio. So for every calorie that you consume, you should consume about 1 milliliter of water. So for someone consuming 2,000 calories a day, about 2,000 milliliters of water or 4 cups would be considered adequate. Okay, and realizing that this is not a perfect system. If individuals are in a hot environment, if they're very, very physically active, those kind of issues will certainly influence someone's total fluid requirements. This was kind of our minimum. Okay, and so that's how we justified that. Okay. All right, and this was just published last week. What we were interested in with this healthy beverage index is it valid? So we had an idea of validity from this Haynes analysis, this proof of concept that it was related to improvements in health outcomes. We also want to know whether it was sensitive to detect changes over time. So if you wanted to use this to counsel individuals to improve their beverage intake habits and you reevaluated them after a period of time, could you pick up changes in beverage intake using this index? And so we had a sugar-sweetened beverage reduction trial going on and applied the healthy beverage index to individuals in this study who had reduced their sugar-sweetened beverage intake over a 6-month period of time. And we found that our healthy beverage index did change in response to the changes in sugar-sweetened beverage intake. So we are happy to have individuals use this. If you're interested in studying it, improving upon it, we're happy to have those kinds of studies going on. Okay, so the other challenge related to evaluating water and beverage intake and our desire to develop a method that researchers and health professionals could more easily evaluate someone's beverage intake. Okay. We are also interested in dietary biomarkers. So if we have time here, we might not have time, but if we have time, I'll mention that. So this is the BevQ. It is a tool that evaluates individuals' usual beverage intake habits over the period of about the past month. And so rather than doing very detailed food records for individuals in a research study, you could administer this tool to them. It's free. We make it available to anyone that would like to use it. We have tested the validity, we have tested the reliability, and we have tested the sensitivity to change. So it appears to meet those criteria, which are important for using them in research studies as a measurement method. The reading level is about 4th to 5th grade, so depending upon the literacy level of the population that you're working in, it's pretty suitable to a lot of groups. And it only takes about 2 to 3 minutes to complete. So many advantages over dietary recalls or long food frequency questionnaires if you're interested in evaluating water intake, sugar sweetened beverage intake, and total beverage intake. The validation studies have been done in adults. We have one that has just finished in children, adolescents, so hopefully those results will be out within the next year. If you're interested in using this, please just email me. We'll send it to you with the scoring instructions. We make it available for anyone who's interested. Okay, I'm going to skip over the biomarker stuff. Because I know some of you have an interest in public health, I wanted to just add in this last bit of research that we've done as part of this interdisciplinary graduate education program. So you guys may remember over the course of a year getting a pamphlet in the mail from your local water utility, and it gives you information on your water quality. And so I had been getting these for a couple of years, and even being an educated person, I was still having trouble figuring out what this water quality report was telling me, and is my water safe or is it not safe? And these things that are being detected in the water, is this a problem or is it not a problem? And so these are called consumer confidence reports. Water utilities are required to send these out every year to consumers by the EPA. When you are trying to help folks increase their water consumption, one of the things that they will tell you sometimes is that they are concerned about the safety of their tap water. They think drinking bottled water might be safer. And one of the things that we heard from individuals in our study was that they were concerned about these water quality reports, and they were more alarmed by them than reassured that their tap water was safe. So when you're doing studies trying to get folks to increase their water consumption, it's something that you might have to address with them, is whether they think their water is safe, whether it is good quality, or whether they feel like they have to buy bottled water, which could be a barrier for some people who should increase their water consumption. When we evaluated the readability of water quality reports, this was a couple of really great civil engineering students that I work with, we found that the water quality reports were written at about the 13th grade level. The National Institutes of Health recommends that your health communication materials be written at about a 7th grade level. So clearly they were way above what could be used by a lot of the public. And one of the quotes that we had, and I have to attribute this great engineering student that worked with us, is that our score was akin to that of the Harvard Law Review for these water quality reports. So are they really doing what they're intended to do in terms of reassure folks about their water quality? Maybe not. We also found that an evaluation of these water quality reports using the Center for Disease Control's Clear Communication Index, which is a tool that you can evaluate your health educational materials with, that the water quality report scored around 50%, and a 90% is considered a passing grade by the CDC's criteria. So a lot of work needs to be done, I think, to improve some of the information that's communicated to the public about the quality of our water in the U.S., which for the most part is very, very good. Okay, so just some future directions that I hope to pursue. We really would like to do a larger scale randomized control trial with pre-meal water consumption. We'd like to include cognitive function measures. I was kicking myself for not doing that with that first randomized control trial, because our participants were saying, I think so much more clearly, I can concentrate so much better, and we hadn't evaluated that. We are interested in studying individuals with prediabetes because of this potential connection with insulin and glucose metabolism. But we were really pleased this year when a translation study was published in obesity, basically using this same approach that we had with the pre-meal water, but it was done in medical clinics in England and a larger scale study. So they had some nice results. Again, the Healthy Beverage Index, we'd like to have an online version and something that can be used for kids, and continue our biomarker validation work. And just lastly, I'm really fortunate to have an outstanding group of graduate students working with me. So this is our Davy Lab holiday photo from last week, really terrific group of graduate students, and then some former graduate students who've gone on to do great things, who really helped out with this water research interest, and some faculty collaborators that I have as well, both at Virginia Tech and in other institutions, and then lastly our funders. So that's all I have, and I'm happy to take questions.
So I can.
Any questions? Questions from the audience?
Everyone's thinking it. Yes.
I like how you finished out with this idea of how we can get the public to the level of what we'll have. And so I was wondering if sort of your opinion is how you recommend, outside of having access to questionnaires for individuals,
How I communicate with them about water consumption. I think the Healthy Beverage Index is our attempt to have a starting point for that. You know, people want to know, just tell me how much should I drink? Tell me what I need to know. And so, you know, when I talk with some groups, I'll use examples like the urine color charts, which are very practical. And in fact, in talking with some of our athletic teams, you know, we say, post those in the bathroom stalls so that the athletes can very quickly get a sense of what their hydration status might be, you know, and you want to be the light lemonade, right? That's what you want your urine to look like. So that's a very practical message, I think, that you can give to people, other than the quantitative stuff like how we design the Healthy Beverage Index, meet those recommendations. Yes.
Are there some things you like in terms of flavorings? People get sick of drinking,
right.
You know, they like a flavor. Are there some things out there that you like or recommend to
right.
use to flavor water?
Right. And so that's something that I think goes really along well with the previous question is, you know, folks taste the same water differently. You can give individuals the same tap water and there's differences in aesthetics, how people perceive that taste. Some people are very sensitive to how water tastes, and they don't like chlorine and they don't like their tap water. And so what you can do is recommend things like adding cucumber or lemon slices or lime slices to help give it a little flavoring, adding frozen fruit. My personal opinion, I'm not opposed to artificial sweeteners, and so I think some of the little flavoring packets that have artificial sweeteners in them, if it helps folks drink more water and it doesn't give them calories, then I think that can be a good strategy too. And there are a lot of those on the market too, good flavoring aids.
Have you been around anyone that is opposed to those artificial sweeteners, and if so, why?
You know, it's a controversial area. There's some research, mostly done in animals, that suggests that they could lead some to increase their calorie intake. Again, it's animal data primarily, but I think that idea got out into the public and turned a lot of folks off to artificial sweeteners. I think some folks also believe they're just not a natural thing. You know, sugar is natural. It comes from a plant. These artificial sweeteners are chemicals. And so some people are just opposed to them, I think, based upon that. And then some people do not like the taste of artificial sweeteners. Some folks are very sensitive to their taste, so they might not like them in those terms. So I think it's, when working with individuals, learning about their individual experience with, do you like this, do you like that, and trying to come up with a variety of options is the best strategy rather than one solution for everybody. Because again, people have different taste perceptions.
Dr. Davy, there are actually dozens of questions for you through the online viewers.
Okay.
So I will start with a couple of them.
Okay.
One of the first ones, if you would like to comment a little bit on different types of water, like alkaline water or filter water, and whether you think there might be any difference between the different types of water.
Okay. So in the studies that we did, we used both bottled water and tap water, and they both seemed to work equally well. We did not test any type of carbonated water or bubbly water, but there has been some research that has suggested that the carbonation or the bubbly types of drinks might impact satiety better than a still or non-bubbly type of water. We haven't done those studies, so I'm not sure about that. And then with the other designer types of water that are out on the market, I'm not familiar with any research that really supports the use of those types of products, but I know they're out there.
There were a couple questions related to the water study that you did with the preloading. You mentioned for consumption of other diet drinks, there are specific questions whether you remember what type of diet drinks your subjects were consuming, or do you have any information on that?
So for the water weight loss trial?
Yes.
So we did not have a lot of diet drink users in that population. They were not big on artificially sweetened drinks. So in general, they were water drinkers, they were coffee drinkers, and alcohol. Those were the beverages, not so much the diet soda. So.
Any more questions from the audience? All right. Thank you very much.
Yeah.
Appreciate it.
Thank you all.